Okay, picture this. We're sitting together at a table, and I'm showing you a product, maybe a shoe. You know when you pick up a shoe in a store and tilt it towards the light to see the details? That's exactly what three.js lets you do on a web page. So what is three.js? Think of it as a JavaScript library that gives your browser its own mini 3D studio. You don't have to mess with complex graphics code. You just set up your scene, and three.js handles all the heavy lifting behind the scenes. Here's how it works. Using our studio analogy, the scene is your room. It holds everything inside. The camera is your eye. You decide where it's positioned and what it's looking at. Lights make the shapes pop. Imagine a soft fill light for overall brightness, and a brighter key light to make edges stand out. Objects are your products. A mesh is basically the object's shape combined with its surface appearance. The renderer is like a projector. It constantly takes what the camera sees in the scene and paints it onto your web page canvas dozens of times every second. Animation is just changing numbers over time. Move the camera a bit, rotate the object a little, and suddenly it feels like you're turning that shoe in your hand. Because every position and rotation is just a number, we can hook it up to G-Sap and ScrollTrigger. Your scroll bar becomes the camera operator. A small scroll gives you a subtle move. A bigger scroll takes you to a whole new angle. Alright, let's talk about this demo. It focuses on one clear idea: use three.js to build a simple 3D scene. Then use G-Sap ScrollTrigger to pin the stage and map your page scroll to two precise motions. First, a full horizontal rotation, then a full vertical rotation. While this happens, the camera and lights also glide smoothly to new positions. This makes the whole motion feel cinematic and super clear. Plus, you get a natural drag interaction with a bit of inertia. It feels like you're holding the object before the scroll takes over. How we build it, starting at the top. Our HTML sets the page language and basic info. The CSS makes sure the page fills the screen and keeps the typography clean and minimal. The import map tells the browser where to grab our tools. 3 points to the core 3 library. 3/examples/JSM points to official add-ons like the model loader. GSap points to the GSap animation library itself. GSap/ScrollTrigger points to the plugin that links animations to your scroll position. This keeps our actual import statements nice and tidy later on. The intro section sets the context and gives instructions. It has our main heading and a short line telling the viewer to scroll. The section with ID = stage is your set. It's a full viewport container that ScrollTrigger will pin. Pinning means when this section hits the top of your screen, the page scrolling stops. This section holds its place while your animation timeline plays out. Giving it an ID makes it super easy for ScrollTrigger to target. Inside that, the div with ID = webgl is the actual screen. three.js creates its canvas element and puts it right inside this div. We use a wrapper div instead of the canvas tag directly. Much cleaner control over layout, stacking order, and interaction. Why this structure? 3 big wins. You get precise pinning and animation control tied directly to the stage. The canvas automatically fills the stage perfectly, no layout hacks needed. You have a clean spot to layer UI elements, like hints or info cards, above or below the canvas using simple z-index without messing with the renderer itself. It just works. So there you have it. The foundation of our 3D scroll experience. We've covered the core concepts, set up our HTML structure, and prepped the stage for magic. But this is just part 1. In the next video, we'll roll up our sleeves and set up modern module, imports for three.js, gltf loader, GSap, and ScrollTrigger. Break down why each tool earns its place in our stack. Show exactly how these pieces work together to create that wow effect. Small request, if this clicked for you, help us reach 200+ likes. It tells YouTube these deep dive tutorials matter. When we hit that goal, I'll pin all demo source codes in the top comment. Subscribe if you're ready for more. Next time we dive into actual code and you'll see how smoothly these tools integrate. Hit that bell so you don't miss it. Thanks for geeking out with me today. Can't wait to continue this journey with you in part 2. Happy coding, and see you in the next one.